Hey guys, welcome back to Law of Creation. Today we're talking about one formula connects cells, stars, and cities. Same math, every scale. I'm David, this is Nebula the physics cat, and she's going to help us navigate through this new connection that we found between the creative intelligence of the universe and when we talk about the intelligence of humans. We're going to be able to connect how, for example, this invention here of a keyboard protector made out of a cutting board and some pads makes it so that when Nebula likes to walk and participate with our videos, she doesn't change the whole program that we're working on. Now, what does that have to do with the creation of life? It's because there is a need, there is a gradient, and our human intellect allows us to solve problems by smoothing out that gradient of a need of, in this case, our program to not be interrupted by the cat. But what happens in primordial life is that we've got all these new gradients forming because of a very dynamic and vibrant pre-life Earth with tectonic plates and jet streams and ocean currents and the pulling of the moon and the light and the dark and the hydrothermal vents. All of these things create like miniature batteries where if a problem could be solved, it would be. And this is where the intelligence of the universe comes in. And this is where we're going to show you our formula that allows all of this to happen. I happen to think you guys are here because you want to hear about physics and the origins of life and how we're not so separate from the universe after all, and how our intelligence is actually the same thing as the intelligence of the universe. But Nebula here would have a different idea. She thinks you guys are here because you want to see her interact and interrupt and show that it's really all about her, this channel, and not physics at all. So in today's video, we're talking about a formula that connects stars, cells, and cities. So let's go ahead and walk to the chalkboard and see if we can make sense of this newfound formula that we have that connects all the creation of stars and galaxies, as well as when humans decide to invent something. It's actually very much related. It turns out that Darwinian selection isn't the only type of natural selection that exists. Today we have natural selection at the level of molecules and atoms, whereby Darwinian evolution starts when life itself begins. So this is it. This is the formula that connects stars, cities, and cells. And we're going to talk about ODC, Optimally Dissipative Configuration. And what this means is that the final configuration, being whether it be a life form or a city or a star, evolves or is naturally selected for because it is the optimally dissipative configuration. And the way that works is with this formula right here. It might seem a little complicated at first, but it's a very universal and simple way to bring all of these things together. So what happens is that, let's say we're designing and building a bridge. The human will select the argument of the maximum, which means the best of the best design within our budget that will allow that bridge to bring whatever resources or new traffic flow that we're looking for as efficiently as possible. So that's not too hard to imagine when we invent bridges or cars. And what's in the parentheses here is the configuration that produces the highest entropy rate. And again, this is talking at the molecular level, at the atomic level. This is what happens. But when we talk in human levels, it means that out of all the bridge designs, out of all the least possible budget possible in the materials, out of all of these, the bridge design or the car design that is most efficient or most attractive and most cost effective out of all of them within the constraints. So when building an invention, we're talking about materials and budget and level of technology that we have. So that's one way that the universe through us creates. So the argument of the maximum would be how we choose the best possible configuration. Out of all the bridge or car designs, we're learning, we're experimenting, we're adapting. Within the constraints of the system, we have our configuration, which is a structure or body that has memory because we can now design based on the old structure. And you might be asking, well, that's understandable, but what does that have to do with the building blocks of life, creating life in the first place? Well, we can use this same formula for exactly that purpose. So what happens in the primordial soup, we've got all these amino acids and sugars and simple elements and minerals that are coming from hydrothermal vents and moving around through volcanoes and gradients in chemical concentrations and tidal waves. And all of that is moving together in this great soup where you've got all these molecules together. And what happens is that the universe, the physics, the thermodynamics of the system will choose that configuration which is able to dissipate that new gradient as best as possible. And so we'll say it again. The configurations, the molecules, the atoms, the amino acids that are able to configure in such a way that they best dissipate gradients that we just mentioned are the ones that the universe will select for. The most dissipative configuration wins, in the same way that the best invention wins. The same way that if you look through the patent office, we'll find that pretty much every single application in there has to do with increasing the rate of something, making a better design of something, making something more efficient, harnessing more energy out of something. Another way of looking at this, if we're looking for all the potential energy in the planet's oil reserves that are made from hundreds of millions of years worth of organic decay, which is how we fuel our homes and cars today. So it's very valuable for humans. And so what we do, we'll invent ways to get to that energy as efficiently as possible within the technology and budgets that we have, is the way by which we're going to harness that energy. And the reason this is a universal concept is because the same thing happens on a molecular level, where the best configuration, the pre-life molecules, are selected because they're able to harness and dissipate potential energies better than the configurations that do not. Right, Nebula? Sounds good to me. And we actually have a working model of how that phenomenon works. So again, it's easy to imagine how when humans invent things, they're looking for the best design, the most efficient design, but how does that work in a prebiotic Earth, and how can we demonstrate it? So I call this the Atomizer, and maybe Kitty's gonna come down for this one because it's gonna make a lot of noise. Ooh. All right, Kitty, okay. Okay, so this is the Atomizer. So all of these ping pong balls, some of them have magnets on them, some of them do not. So what we have here is a very microcosm, the head of a pin amount of atoms and molecules that might occur anywhere in the universe. Right now they're just sitting still because they're at equilibrium. This is what things might look like, let's say, on the moon's surface where nothing much is going on. But if you go to a planet like Earth and many others in our solar system, a lot of things are happening. It's very dynamic, it's very vibrant. It's almost like a living thing in and of itself. You've got all sorts of, again, the jet streams and the ocean currents and the volcanoes, all creating new vibrant gradients, whereby if there is an opportunity to harness that gradient, the universe selects for it through ODC, Optimally Dissipative Configuration. So what happens if we activate this or give it a driving force, move it around with ocean currents, hit it with radiation, it's going to come to life, and new structures and configurations are going to naturally be produced. And it's important to remember that the final configuration is never predetermined, but is a result of the parameters and constraints that we talked about before. So let's see if we can create something today. So let's see what happens if we Well, let's see what we've created today. Remember, one formula for all stars, cities, and cells. So we've got a few interesting configurations happening here. So this is what you might find in the primordial soup, in oceans, in the atmosphere. Things that look weird and new, and for the most part, nothing's going to happen. But with all the mixing and currents and radiation that occurs, and these new gradients that are appearing, once in a while, these configurations will be able to harness these gradients. And when they do, it's like a one-way street. They don't come back because they're the most dissipative, they're most exothermic, so they are less likely to turn back, and that's what makes them optimized for being most dissipative. And as these gradients form in the early Earth, those molecules and configurations that are able to stabilize said gradients will learn to stay and create new microgradients and eventually give us what we might call life. So this is how we have one formula for the creation of cities, cells, and stars. Kitty loves to participate. And what this large diagram there shows us, and that one formula, that's the second law of thermodynamics that says that as time goes on, everything dissipates more and more and more. So we might be asking, well, if that's true, then how come we see all this order and beauty and life? And the reason for that is that those pockets of order are allowed to emerge and be created per the second law of thermodynamics as long as they produce at the end more entropy than it took to build them in the first place. This is analogous to how if we're going to invent something or build a bridge, the resources invested in building that bridge have to be less than the benefit we're going to get from that new traffic flow or resources attained. So what this diagram shows is that planets are created by stars doing their thing. Stars are created by galaxies, and everything originates from the Big Bang. And sometimes on planets, if they're vibrant and have a lot of things going on that are dynamic, those volcanoes, hydrothermal vents, so much going on and the right minerals around, then you start to have even more complex structures, and eventually you get dinosaurs and humans and cell phones. But there's an order to it. You don't get cell phones right from the planet. It has to go through the humans first. You don't get star systems out of dinosaurs. It's the other way around. It seems very obvious, but you see how there's an order to things. But they're all using the same formula. In each case, the planet and what's on it are helping the star system dissipate. Each individual stars and nebulae are helping the galaxy dissipate. The dinosaurs and the humans are helping whatever's happening with the planet dissipate. So I hope this is starting to make sense. I know I'm probably throwing a lot at you here. Ooh, it's getting cold this time of year. I understand now why the original mad scientists wore these lab coats, because maybe their secret lairs and castles weren't all that warm all the time. Even Kitty likes to warm up. One formula, all different scales. It shows that Darwinian evolution, for example, is one type of ODC, or evolutionary system, that pertains only to life. But with ODC, Optimally Dissipative Configuration, we have a universal natural selection of the most dissipative structures, including Nebula here, who wasn't always a large physics cat. She was once a tiny little physics cat, and every part of her being, from how cute she is and her behaviors. So for example, when she finds a spot to lay down on the floor, she'll find a nice sunny spot to optimize the heat transfer energy of the sun, as opposed to the cooler spots. So I appreciate you guys joining us once again at Law of Creation, and today we explored the one formula that works for stars, cities, and cells. We've been taught that natural selection has to do with life. Whatever is optimized for survival is what comes in the next generation. But with ODC, Optimally Dissipative Configuration, we have natural selection in a universal way. It shows why stars form planetary systems. Oh, and Nebula wanted to remind us that we do have about a dozen illustrated books at Amazon.com. So Nebula and I thank you for joining us once again at a look at the one formula that applies to stars, cities, and cells. And let us know if we're going too fast with this. Is this too obvious? Is it annoying? Is it thought-provoking? Did you already know this? And are there things that we could spend more time on or less time on? And we'll make it part of the future videos. And we'll see you next time at Law of Creation. See, bye-bye, Nebula. Bye-bye, Nebula. Bye-bye, Nebula.